Think about your body like it's this incredibly complex, bustling city. What are the walls that protect the neighborhoods? The slick highways that let things move around? The communication systems that keep everything in sync? That's what we're getting into. The amazing, elegant solutions our bodies use for both architecture and manufacture.
So, here's our game plan. First, we're going to look at the body's smart surfaces. These are the membranes that line and protect everything. Then, we'll shift gears to the chemical factories, the glands, and see how they work. And finally, we'll put it all together to see how these two create this perfectly integrated inner world we all have. Okay, first up, our body's smart surfaces. You can think of these as the body's internal wallpaper or its high-tech packaging. They cover us, they line us, they separate everything. And trust me, they are so much more than just simple dividers. So the official definition sounds pretty simple, right? A thin sheet of tissue. But don't let that fool you for a second. These sheets are the absolute unsung heroes of our anatomy. They're the barriers, the pathways, and the protective layers for pretty much every single part of our body.
All right, let's go on a little tour. Now, body membranes are basically split into two major groups, and it all comes down to what they're made of. And understanding the split is totally key to getting what they do.
And here it is, the key difference. On one side, you've got epithelial membranes. These are a two-layer deal, a top layer of epithelium with a supportive connective tissue layer underneath. Then, on the other side, you have connective tissue membranes, which are pure structure. They're made only of connective tissue. That simple difference in their makeup completely changes their job in the body.
And this just shows you the incredible variety just within that first group. You've got mucous membranes lining all the tracts that are open to the outside, like your airways, acting as this amazing protective, slimy barrier. Then you've got serous membranes, which line our closed body cavities, creating this super slick, friction-free environment for organs like your heart and lungs to move around in. And finally, there's the cutaneous membrane, which you're probably a lot more familiar with than you think.
That's right, it's your skin. This is the one we all know. It's basically our personal suit of armor. It protects us from the entire outside world and even helps control our temperature. It is the ultimate protective barrier.
Now, let's talk about that other category, the pure connective tissue membranes. And the perfect example here is the synovial membrane. Remember, no surface layer, just connective tissue. Its one and only job is to line our joints and ooze out this stuff called synovial fluid. Seriously, think of it as the body's own motor oil, keeping our joints moving smoothly without any grinding or wear and tear.
Okay, so we've covered the architecture. Now let's switch gears and talk about the manufacturing side of things. We're moving from the body's surfaces and linings to its super specialized chemical factories, the glands.
So what exactly is a gland? Well, you can think of it like a tiny, microscopic factory. It's just a highly organized team of cells with a single mission: to make and release specific chemicals. And these products can be anything from simple stuff like sweat and saliva to the unbelievably complex hormones that run our entire body.
How we classify glands really just comes down to logistics. It's one simple question: how do they deliver their goods? Do they use a dedicated pipeline, what we call a duct, to get their product to a very specific spot? Or do they just dump their cargo directly into the body's main superhighway, the bloodstream? This one little difference defines everything about what they do.
Now, for those glands that use ducts, the exocrine glands, there are actually three pretty cool ways they make their deliveries. First up is merocrine, which is the neatest method. The cell just kind of spits out the product in a little bubble, no harm done. Then you have apocrine, which is a bit more dramatic. A whole piece of the cell actually pinches off with the product inside. And finally, there's holocrine, the most extreme of all. The entire cell literally self-destructs to release its contents. That's how the oil glands in your skin work. And all that brings us to the two major glandular systems in the body, which are defined by that one key difference we talked about: ducts versus no ducts. Okay, so here's the big split. Exocrine glands are all about local delivery through their ducts. Think about sweat cooling just one patch of your skin, or saliva right there in your mouth. Endocrine glands, on the other hand, are the complete opposite. They are totally ductless. They use the bloodstream like a global broadcast system, sending powerful hormone messages to the entire body all at once. And this endocrine network, wow, it includes some of the most powerful players in the whole body. You've got the pituitary gland, kind of the master gland running the show from the brain. The thyroid in your neck is like the body's thermostat, controlling your metabolism. And the adrenal glands, they give you that fight or flight rush.
Together, they're this invisible, high-speed communication network.
But what about glands that can do both? Well, nature loves to be efficient, so of course, we have mixed glands. These are the multitaskers. They wear two hats, pulling double duty with both exocrine and endocrine functions.
And the absolute superstar example of this is the pancreas. On one hand, its exocrine job is to pump out powerful digestive enzymes through a duct right into your intestine. But at the same time, its endocrine job is to release hormones like insulin directly into your blood to control your blood sugar. It is a true dual-function powerhouse.
All right, let's tie this all together. We have the architecture, the membranes, and we have the manufacturing, the glands. So how do they work together to create this integrated inner world? Well, it's really this beautiful synergy, right? The membranes build the rooms, the walls, and all the protective barriers, and then the glands get to work inside that structure, manufacturing all the chemicals and sending out the messages that keep the whole system running, talking to itself and responding to the world.
And that's really the big takeaway here. This isn't two separate topics. It's one incredible integrated network. Everything from the physical shield of your skin on the outside, all the way down to the invisible hormone commands that are guiding your cells deep inside. It's all membranes and glands working together in this silent, seamless partnership.